Hello everyone, today we'll talk about the solution to the problem find the student that will replace the chalk. The basic simulation for this problem is very simple. It's in lines 4 through 7. We go through everything in our chalk array and we have our counter k at the beginning. We use enumerate because we are not only interested in the value in the array but also the index of that value. And in every step we subtract the value from our current counter, and if the current counter has become negative for the first time, we return the index we're on. So this is a straightforward simulation of the process that is being told to us, that is being explained to us in the problem statement. And now the only problem here is that if the values in our chalk array are small and the counter is big, then the number of operations we have to make, the number of subtractions, like on line 5, is proportional to the size of the counter, the value of the counter. And there is an easy way of dealing with that, and that way notices the following thing. Whenever we have to run through this for loop multiple times, because to make sure that the counter becomes negative at some point, we should have something like a while true around these lines 4 through 7, then whenever we run through the whole chalk array and the counter is still positive, the counter has become smaller. The value that has been subtracted from it is exactly the sum of what we have in our chalk array. So we could first subtract the sum multiple times until we get the counter to a value that's smaller than the sum and then run our for loop. That's also possible. But still, if for instance we have only a single value in the chalk array and the counter is big, then again we might have to do it the number of times proportional to the value of the counter at the beginning. But the operation that allows us to subtract the sum of chalk from k as many times as possible until we get something that's smaller, that's non-negative and smaller than that sum of chalk, is exactly the modulo operator. So in other words, we can just modulo the counter first with the sum of chalk, leaving us something that's smaller than sum of chalk. And in that case, we can be sure that when we go through all the elements of chalk, at some point on line 7, the counter will become negative, in which case we just return the index and we're happy. There's nothing we have to do here, because mathematically we always will return at some point while running this for loop.